Algebra I Honors, Lesson 5.6, Geometry, Parallel and Perpendicular Lines, and 5.7, Statistics, Scatter Plots, and Lines of Fit. So the theory is that all of these fit quite nicely into what we're doing here. And more or less they do. So we've been talking about graphing lines, and one of the many things that pop up are what's going on with parallel lines. Well, for two lines to be parallel, they have to have the same slope or both undefined slope. This is a big deal in math, mostly because it makes us write really cool problems for you. I'd love to say there was more to it than that, but sometimes there isn't. Perpendicular has this horrible expression called opposite reciprocal slopes. It means flip it and multiply by -1. So if slope is 2/3, perpendicular slope is -3/2. Flip it, multiply by -1. You could also say that you multiply the two slopes together and you will get -1. 2/3 times -3/2 equals -1. So that's another way to do it. So here's all the problems we write. Write the slope-intercept form for an equation of a line that passes through this point and is perpendicular to this. So the first thing we have to do is find the slope of this line. The best way to do it is to put it into slope-intercept form. So now I say let's write one that's perpendicular. So if the slope is -1/4, then the perpendicular slope is, this is m perp, equals flip it, multiplied by -1, 4. So now we use point slope to write an equation. The one in slope intercept, so we'll have to mess with it. Y minus -3 equals 4 times x minus -2. Y plus 3 equals 4x plus 8 minus 3 minus 3. Y equals 4x plus 5. And that's how we do it. It's a lot of work. This is called algebra. You need to be fast at it and crank it all out. There's a lot going on. So, write the slope-intercept form of equation for the line that passes through that point and is parallel to this. This one's a little bit quicker, a little bit easier. We say, oh, m equals -3, m parallel, and I almost always write this. I recommend you do too. It's a good habit. Equals -3. So now we write y minus -2 equals -3 times x minus -1. Y plus 2 equals -3x minus 3. Y equals -3x minus 5. Piece of cake. That one's definitely an easier problem, but you gotta get good at finding your slope, flipping your slope from perpendicular, point slope, reducing. So, outline kite is shown on a coordinate plane. Determine whether AC is perpendicular to BD. And this is from geometry. This and this should be perpendicular in a kite. So, let's find the slope of AC. We have 5, 5, and 7, 1. 1 minus 5, 7 minus 5. -4/2 equals -2. Down to the right, pretty steep slope, yes. Other one, 8, 4, 0, 0. I'm going to do it this way, x2, y2, x1, y1. M equals 4 minus 0 over 8 minus 0 equals 1/2. these are indeed perpendicular. That's it, parallel and perpendicular lines. Get good at it, get fast at it, don't ignore it and say, it's not that big a deal. Another piece of slope pops in here. We have what we call correlation. So we do a scatter plot. We get a bunch of data and we just plot it and we get, a ton of dots. Well, the question is this data any good? And here we have a decent positive correlation, meaning that it seems to go up as it goes from left to right for x, and over here it seems to go down. It goes from left to right to x. Here, a lot of people say, oh, I see a line there. Well, this data's all over the place. You can probably put a line there. So that doesn't really have correlation, and your calculator and computer can tell you when that happens. But scatter plots are used to represent data that don't necessarily lie on one line. What does each type of correlation above mean? Well, I just said. This one is positive. Data goes up to the right. This is negative. Data goes down to the right. So we're basically just describing the data. This is none. Data goes everywhere. Determine whether each graph shows a positive correlation, a negative correlation, or no correlation. This one looks positive, kinda. So I love the ish at the end of many of my words. Positive-ish. I mean, it definitely goes up to the right, but when you get this data point way the heck out here, you got some interesting things going on. It does look like the more fat grams something has, the more calories there are in it. I'm sure some food is an exception. This is definitely negative. It looks pretty sharp to me. And I won't even put an ish on the end of this. If the data has a positive or negative correlation, we can kind of give our best line in there. And we do it basically the way I just showed you. I just throw a line in there and pray that that's the best one we're going to get. Again, your calculator and your computer can do a much better job, but that's what we're working with for now. So here we go. Table shows an estimate for the number of bald eagle pairs in the United States. I think we've heard about bald eagles before. It's almost like there's an environmental message. Since 1985. So we got 3, 5, 7, 9, 11, 14. 3, I'm going by twos. 5, 7, 9, 11, 14. And it goes from 2,500 to 5,800. So I'm going to go up by thousands, I think. I can do better than that. I'll go up by 500s. But I won't quite get that. I'll give it 5,000. So I'll start at 1,000. 1,000, 2,000, 3,000, 4,000, 5,000. Notice how quickly I can do that. It definitely takes practice to get good at that. 3 is 2,500. 5 is 3,000. 7 is 3,700. 9 is 4,500. 11 is 5,000. 14 is 5,800. Make sure I got that right. Yep. So, great, got a line. I'd get a ruler and do this part. Draw it through. And it's not bad. I think I can do slightly better. This is not a very straight line. Doing the best I can here. this point, I usually say hits this point. So that's one of our points, 3, 2500. And pretty close to the 11 point, 11, 5000. So we picked a couple of points. I don't know what D is supposed to say here, but let's do what I would do. Find your slope and write the equation on the line. M equals 5,000 minus 2,500 is in millions. Bald equal pairs. Isn't that interesting? I thought it'd be higher than that. It's moving along nicely. I'll give it that. Over 11 minus 3. 2,500 over 8 equals, I think we're looking at, well, we'll see. Calculator that one out. Yep. 312.5. That means that every year we seem to add 312.5 pairs of bald eagles. So what's my equation? I'll go with the top one. Y minus 5,000 equals 312.5 x minus 11. I'm going to cut to the chase just because I don't have room to write it all out. 12.5 times 11, negative 11 plus 5,000 equals 1562.5. So we get 312.5 x plus 1562.5. And I would always check that. So I put in 3 here. I get very close to 900 plus 1,500 is pretty close to 2,500. So that looks good. Now, estimate the number of bald eagles in 1998. This does since 1985. So 1998 would be 13 years later, which is kind of a dumb thing to estimate. 10 and 3, because I mean we could just say it's going to be about 5,600. So 1998 minus 1985 equals 13. Y equals 312.5 times 13 plus 1562.5 equals about 5,625 pairs. I guess it's important to have a mate. Or you always see bald eagle in pairs. I don't know. So that's just an example of how we can take some data, graph it, and turn it into something. A lot of teachers are like, yeah, that's important, but don't worry about it because they're busy teaching you algebra. That is what we're doing with algebra. Can we take that data and turn it into something useful? It'd be nice to know if this stayed linear, how many are now in the year 2016? How many should be in the year 2025? And get a rough idea so we can do something with that data if we needed to. That is it. Good luck and happy mathing.